Okay, we're going to try to find the nth term for this particular sequence, and first of all we have to start by trying to find a difference between each of the terms. So the difference between the first and the second term, between 4 and 14, is 10. The difference between the second and the third term, well, that's 16. The difference between the third and the fourth term, well, that's 22. And the difference between the fourth and the fifth term is 28. So I can see at this stage that we don't have a constant difference, so we now have to go again. So the difference between 10 and 16 is 6, the difference between 16 and 22 is also 6, and the difference between 22 and 28 is also 6. So, remembering that at this stage, if I find a constant second difference, I know that this is a quadratic sequence. I have to halve this number to get the first part of my rule. So if I halve 6, I have 3, so the first part of my rule is 3n squared. Right, now I want to create a sequence using 3n squared by substituting each of these term numbers into this particular rule, and I want to compare it to this sequence. So if I start with n is 1, so that's 3 times 1 squared, I have 3. Where n is 2, 3 times 2 squared, or 2 squared is 4 times 3, gives me 12. Where n is 3, so 3 times 3 squared is 9, 9 times 3 is 27. Where n is 4, well, we've got 3 times 4 squared is 16, 16 times 3 is 48. And where n is 5, 3 times 5 squared, or 5 squared is 25, gives me 75. Now I want to have a look and see if I can see a difference between 3 and 4, difference between 12 and 14, 27 and 30, and so on. Well, I can see that I have to add 1 to 3 to end up with 4. I have to add 2 to 12. I have to add 3 to 27 to equal 30, 4 to 48 to equal 52, and 5 to 75 to equal 80. So my first part of the rule is 3n squared, and I can see here that my second part of my rule, 1, 2, 3, 4, 5, is exactly the same as n. So the second part of my rule is plus n. 3n squared plus n.